we are group J060, and this is our exposition assignment on TikZ plotting. So we will be covering the following points in our exposition assignment. So what is TikZ? TikZ is a package of LaTeX. It is basically a tool which helps us plot lines and graphs, vectors. It also helps us plot different sort of points and different sort of curves, and also various shapes. It also helps us plot circuits, which we will be seeing future in the demonstration of this exposition.
Now let us discuss the key features of this package. The first feature that gives it an edge over other packages is that it is integrated within LaTeX. Since TikZ is native to LaTeX, it ensures seamless integration with mathematical expressions, text formatting, and referencing within documents. This eliminates compatibility issues that often arise when using external image formats like PNG or SVG files inside LaTeX documents. Secondly, is its precision and scalability. TikZ provides precise control over positioning, sizes, and alignment, making it ideal for technical diagrams and plots. Unlike external images, TikZ-generated figures scale perfectly without pixelation, maintaining high resolution in both PDFs and prints. And lastly, is its customization and aesthetics features. It allows full control over colors, line styles, node shapes, and annotations. The styling, for example, colors, thickness, labels, can be modified using consistent LaTeX formatting. Now let us look at a few demonstrations using this package.
This is example 1, and here we are making a flowchart which helps us go through the decision-making process. We first define the document type, which is an article here, and then we import TikZ. We then load the necessary libraries, which are mentioned in the first few lines of the code right here. We then start with making the elements of the flowchart. Here we have a red colored rectangle, which has rounded corners, and this denotes the start and stop part of the flowchart, followed by the blue rectangle, which tells us about the processes, process 1 and process 2. Then we have the yellow shape, which is a rhombus, which tells us about the decision making of the flowchart, a yes or a no, a condition to be more specific. We then start with the document and start drawing the flowchart. This is denoted by begin document and begin TikZ picture. We have nodes which help us in connecting the various elements. We have the start node, which is right here. Then we have, here it is mentioned process below of start, which tells us that below of start we have process 1. Then below of process 1 we have the condition. To the right of the condition or the decision we have process 2. And below of decision we have the stop rectangle. To interconnect these elements, we have arrows. Here, these are quite self-explanatory. To be more specific here, we have draw arrow, decision east, which means that to the east of decision, which means to the east of condition, and to the west of process 2, which means to the west of process 2. If the condition is yes, we interconnect both of them. And similarly, to the south of the condition and to the north of stop, we have an arrow which gets directed if the condition turns out to be false. When we are done with our code, we have end TikZ picture, which helps us come out of the TikZ environment. This is how we make the flowchart for the decision-making process.
The next code we have generates a Cartesian plane with a parabola, labeled axis, and marked points. We already have the necessary TikZ packages imported here, so we can directly proceed with the code. So, to begin with, we start the TikZ drawing environment using begin TikZ picture code. Next, we draw a light gray grid with 1 centimeter steps using this code, ranging from minus 3.9 to 3.9 on the x-axis and minus 1.9 to 4.9 on the y-axis. The next 2 lines of the code draw the x and y axis with arrows and labels them. Moving on, we draw the parabola that we need to plot using this code, which plots the graph of y equals to x square. Using this code, we can plot it in the domain of minus 2 to 2. Next, we plot the points on this parabola using the upcoming lines of the code, and we plot the points 1, 1, 2, 4, minus 1, 1, and minus 2, 4. These are the points that are plotted using this code. And to end the code, we end it with end TikZ picture.
So in conclusion, TikZ is one of the most versatile packages LaTeX has to offer, in which you can create such nice flowcharts, vector graphics, 3D plots, and such circuit elements as well, and make it as much as customized as possible.